a good morning. Hope you're all safe and please take care about your family members. Now we will discuss about the 2A group elements, some general properties there. In general properties, like what we have to learn means like atomic radius, how that vary, like periodic properties as we know, ionization potential, electronegativity, electropositivity. Okay, so of course their oxidation number and valency, so those we have to discuss actually. So here atomic radius, if you see from beryllium to, actually these are the group elements like beryllium and magnesium and Mr. calcium and strontium, barium. So top to bottom what happens, see from top to bottom, if you see this atomic radius increases, because as of this beryllium have 2s, actually 1s and 2s, means first shell and second shell it have. And magnesium, if you see 3 shells, like number of shells increases. I won't waste time. So beryllium to Mr. barium, what happens? Atomic radius increases. Atomic radius increases. Similarly, so that beryllium to barium, IP decreases. Why? Atomic radius is inversely proportional to ionization potential. Everybody knows this. So when the radius is small, attractions are less, so then you can easily remove electron. So beryllium to barium, radius increases and IP decreases. So electronegativity, same actually from beryllium to barium. What happens? This electronegativity decreases. Okay, so electropositivity means losing tendency. Electropositivity means what? Losing tendency of electron. From beryllium to barium, what happens? This electropositivity increases. Okay, so next, the most important things, one by one we are learning. So first atomic radius and ionization potential, electronegativity, electropositivity. Electronegativity means attracting tendency. Electropositivity means losing tendency of electron. Okay, next this fifth one, if you see melting point. Okay, see this melting point and boiling point and those actually depends on their structures. Okay, so if they have a closed structure and having a very small size, certainly they have more attractions. So beryllium has a more melting point, means more temperature is required to melt that one. See, actually this is having HCP structure, HCP, hexagonal close packing. So actually I will write here beryllium and magnesium has both HCP structure. You will have a solid state, separate structure you have, separate chapter you have to learn all these structures. Solid state anta ಒಂದು chapter ಇದೆ. So beryllium, magnesium, HCP you have. Okay, HCP means hexagonal close packing, and Mr. Calcium and strontium and barium, if you see, they have a CCP, cubic close packing. Those are all structures and full explanation, number of atoms in these structures, those everything we will learn in solid state chapter. Okay, so but simply now remember the beryllium and magnesium has a hexagonal close packing structure, and the calcium, strontium, barium, they have a CCP, cubic close packing. Simply we call it FCC also, face centered cubic. Okay, so these all are important for you. So please remember beryllium and magnesium HCP and calcium, strontium, barium CCP. Okay, so based on structure you have this melting point order. So you remember this magnesium have less in options. First you have to see either melting point or boiling point question if they given. So in which option magnesium has least, you have to keep in your mind. Okay, and you have to check first. So luckily if you have in one option magnesium have least given, so you can go through that answer, remaining unnecessary for you. Understanding what I am saying? Melting point and boiling point will be least for magnesium. Okay, so due to its softness and everything, its structure and everything. Why beryllium has more in both cases? Because of its small size, it has a close packing. So attraction between nucleus of one atom and electrons of other atom have more, are more actually. What I said understood? I repeat. As beryllium is a small nucleus of one atom and electrons of one atom, between them there will be more attractions. Okay, so understanding, no, nucleus means positive and electrons means negative. Certainly those are more. Okay, what more? Attractions are more. Certainly this beryllium have most somewhat strong structure. Certainly it requires more melting point and boiling point. You have to just remember these two. Beryllium has more in both cases and the magnesium has least in both cases. Okay, I won't waste time. Next, come to density. Density is not in our hand. Density always depends on mass and volume. So density means everybody knows mass by volume. So mass, however, is more for barium because as going down atomic weight will increase, no, gram atomic weight. Certainly barium has more, strontium has more. But why calcium is least? Certainly volume is a matter there. Okay, so volume is a matter. That's why it's volume is more actually in CCP language. We will calculate everything, volume in HCP, volume in CCP, everything in solid state you have. So don't worry. So maybe that volume is somewhat more. That's why calcium has less actually. So beryllium and magnesium, beryllium, strontium, and barium you have like this. Got it, everyone? So this is about density. So barium has more. So certainly barium has more. But what is the reason behind it? Barium has more mass. Almost have these solid structures. Certainly volume won't affect much, but due to different structures, volume also affecting their densities. This is the order of density. Please remember all these things. So these are about some general properties, and few more we have to learn. That is basic nature and metallic nature. Basic nature and metallic nature. What happens? So as going down actually from beryllium to barium, this basic nature increases, metallic nature increases because electropositive nature increases, so they can easily lose electron. Yesterday I told you about ionization potential. These can lose 2 electron. What these means? These alkaline earth metals can lose 2 electrons. Understanding? So that's why they have IP1 and IP2, because their electronic configuration, you know, NH2 is the general electronic configuration. So as going down, they have a great tendency to lose electron because IP decreasing. So less amount of energy required to remove electron. And come to oxidation state. Next point. What happened oxidation state? So oxidation state of 2A group elements is always +2, oxidation state. And come to valency. Valency is actually beryllium, and not only just generally I'll tell you first. Beryllium is exceptional here, that's why I'm telling you. So valency, if you see, general valency is 2. I told you, do you remember or not? Up to 4A group elements, valency is group number. Up to 4A group elements, that oxidation state is plus group number. Do you know or not? Do you remember or not? I don't know. But in redox reaction chapter also I told you that alkali metals always +1, alkaline earth metals always +2, I said. Correct? So in that way, oxidation state is always +2, no change in it. And valency also they have 2 because they can lose 2 electron. Certainly they exhibit +2, means they have valency 2. But beryllium general valency 2, but beryllium maximum covalency is 4. I'll show you some compounds. Okay, beryllium can have a 4 valency actually, but please remember right now, just in this class only I'll show you where beryllium exhibit 4 valency. Covalency means by using empty orbitals, if they form extra bonds, that is called covalency. I told you already, do you remember or not? Maybe at the time of chemical bonding we had like this. What I told you, that like NH3, if you see, NH3 valency is 3. In NH3 valency is 3, but in NH4 plus the covalency we call 4 because nitrogen utilizing one empty orbital for bonding actually. So lone pair is utilizing or empty orbital utilizing for bonding. Then we use one word, covalency. Valency extra, covalency. Getting everybody? So beryllium like that show 2 valency, but it can have a maximum covalency 4. That means in very few compounds, beryllium can have 4 valency, means it can form 4 bonds. That's the meaning. Understanding? Like ammonia. Why I give an example, understand? Just for information. Ammonia have valency 3. Here nitrogen is bonding with the 3 hydrogens, but by using lone pair, nitrogen forming bond with another hydrogen as H plus. So NH4 plus, if you see, the covalence is 4. Got it everyone? So this is about some general properties of Mr. Alkaline earth metals. Please have a screenshot please everyone. So atomic radius, what happens I told you, and IP what happens, electronegativity what happens, and Mr. what we call electronegativity, electropositivity, melting point, boiling point. Who have very less melting point and boiling point? Magnesium. Who has highest? Beryllium. Okay. Oxidation state 2. Valency 2. Group number, because these are 2A group elements, no. But beryllium is exhibiting 4 maximum. Okay. Because of its small size, and beryllium has covalent nature actually. Because all these metals ionic nature they exhibit. But beryllium compounds have covalent nature. Those also we will learn. So now our next concept is that only chemical properties of 2A group elements. Just normal I tell you. First one is reaction with O2. Reaction with what? O2. So with oxygen, you can say, or reaction with air, right? You can say combinedly, we can learn one by one. Reaction with air means what? Reaction with O2 and N2 actually. Okay. So alkaline earth metal I am writing as M here. M means all like beryllium, magnesium, calcium, strontium, barium. So 2A group element. When react with O2, you will get MO actually. Oxide. Okay, what is this? Oxide. So what is this? M here. M means is beryllium, magnesium, calcium, strontium, barium. Anything. M can be 2A group actually. Okay, but M when react with O2, it can form superoxide. That means you will get MO2. Okay, M. But what is M? Is calcium and strontium, barium, but not that beryllium and magnesium. Beryllium and magnesium forms only oxide. This is a very clear point. What is this? Peroxide. So how you are deciding peroxide? Very simple. Alkaline earth metal, sorry. Alkaline earth metal is +2. So if you take some like barium oxide example like this, BaO2, if you see, barium which group? 2A group elements. Its oxidation state is +2. That means oxygen has a what charge here? O2 -2. So O2 -2 means it is a peroxide or not? Tell me. It is peroxide. Got it? Otherwise, you want in this way, like BaO2. You can learn like this. BaO2. I want oxygen oxidation state. 2x plus barium +2. Barium +2 now. So you have 2x plus 2 is equal to 0. That implies 2x equal to +2. That implies, sorry, 2x equals to -2. That implies x is -1. -1 means that is what? Peroxide or not? That is peroxide. Getting sir everyone? Okay. So BaO2 if you see, barium +2 and O2 -2. O2 -2 means peroxide. BaO2 I given oxidation state. Oxygen oxidation state I was given. So that's why 2 oxygens are there. I took 2x here. So barium is alkaline earth metal. I shown in previous. Barium alkaline earth metal oxidation state is +2. That's why I have written +2 equal to 0 because no charge on it. So what I said here, oxides and peroxides are forming. when this alkaline earth metal reaction with oxygen, excess of oxygen, so when used, then only peroxide. Oxygen must be excess. Otherwise, these also form oxide first. Who is calcium, strontium, barium. If oxygen is in excess, then along with oxide, peroxide will form. Means first who is forming by reaction of all these metals with oxygen? First what is forming here? Oxide. Next, when oxygen is increasing, then peroxides are forming. But who cannot form peroxide? That also you have to write here. Beryllium and magnesium can't form, cannot form peroxides actually. So this is very, very important. Okay, important point this one. You have to know. And next, with nitrogen, what happens? So I told you alkaline earth metals with oxygen means I written air, no? So air consists of N2. So all these M plus N2, you will get what? Okay, M3N2 you are having. M3N2. Why? Alkaline earth metal valence is 2, but nitrogen valence is 3. So like this. So M3 N2 you are having. What you are having? M3 N2. If it is magnesium, magnesium nitride. As going down, reactivity increases. Remember this one. Okay. So if you want example, you can write like this. What like magnesium. Okay. When react with N2, you will get Mg3N2 magnesium nitride. Got it, sir? So charges, I think you know, Mg plus 2 and 2N minus 3. Okay, because nitrogen is more electronegative, no? That's why. Okay, next come to second one, that is reaction with H2. Reaction with H2. So as going down, reactivity increases. Okay, but beryllium is a less reactive, but beryllium hydride is covalent. Remember that one. So same story, M plus H2, you are having MH2. Why? Alkaline earth metal, no? 2 is the valency. Okay, so this is very, very important. Suppose if you want beryllium, okay, so beryllium hydride, it cannot be direct. BeCl2, beryllium chloride, you have to react with LiAlH4. LiAlH4. Then you will get that BeH2. Beryllium hydride cannot be prepared directly. So remaining is like AlCl3 you will have, and LiCl you will have like that. Okay. So of course it's not balanced, but you have to write. Yeah, balanced also I think so. Yeah, 4 chlorines, everything. BeCl2 with LiAlH4, lithium aluminium hydride. This is a reducing agent. Even in organic chemistry also you know this. Reducing agent LiAlH4, lithium aluminium hydride. Then you will get beryllium hydride. So, but remaining all can prepare directly actually. Okay. So, and one more important thing is CaH2, calcium hydride, is called hydrolith. Okay, hydrolith, LYPH or LIPH. Okay, because few of our students will ask spellings also, because they will have a neat question. CaH2, hydrolith. What is that? Hydrolith. Remember, hydrolith formula they can ask. Hydrolith is CaH2. Important. Please write it down, all these things. So we learn reaction with air and reaction with H2. So with air, I told you, mainly with oxygen, there are oxide and peroxide. Who is forming peroxide? Who is not forming peroxide item? Please have a screenshot. Got it, sir, everyone? Thank you. Now we will discuss about Mr. Reaction with halogen actually. Okay, reaction with what? Halogen. So reaction with hydride also. Reaction with hydrogen, hydride. In hydrides, what is the hydrogen oxidation state? -1. Told you many times. Hydrogen with metals, -1. Hydrogen with non-metals, plus. Just remember electronegativity values, shortcut, what I was given. so that you can say charges very clearly. So next, third one is reaction with first halogen, I'll tell you, because oxygen, next followed by hydrogen, next halogen. So all, as I said in previous, M with X2, you will get MX2 because X halogen, halogen valence is 1. This alkyl earth metal M means it's 2, so MX2 you are having. So what I am saying here, M means like beryllium, magnesium, calcium, strontium and barium. And Mr. X is a fluorine, chlorine and bromine, iodine. So M reactivity as going down increases. As of halogens, fluorine is more reactive. So those reactivities also remember everyone. You write down while what I am saying, you write down everything. That's better to you. Okay. So beryllium, magnesium, calcium, strontium, barium. Who react fast? It's beryllium. No. As going down, reactivity increases. Correct? Huh? So barium has more reactivity towards halogen or whatever. And X, if you see fluorine, chlorine, bromine, iodine, fluorine is more reactive. Even towards reaction with air, even reaction with hydrogen, who react fast means this is the order. So beryllium less than magnesium, less than calcium, less than strontium, less than barium. Actually, this is order of what? Reactivity. Okay, very important. And come to suppose beryllium halides. If you see, BeCl2 is covalent. BeCl2 is covalent. Very, very important. Please listen carefully. BeCl2 is covalent. Remaining all are ionic. Okay. So even suppose magnesium chloride, like that, if you see, they are ionic actually. See, beryllium chloride exists in two ways actually. Beryllium chloride in vapor phase exist as dimer. Exist as what? Dimer. So how that exists, I'll show you here. Beryllium, and here you have a Cl like this, and Cl, and beryllium, here you have a Cl and Cl like this. Okay. So actually beryllium, now it forms some bond is like this towards beryllium, and now towards like this. So this is dimer. So BeCl2, dimer it is. BeCl2. Okay. So actually, if you see, the most important thing here, what happens if you see beryllium configuration, if you see 1s2, 2s2, that's it. Correct? Huh? It's ground state electronic configuration. If you see, its configuration, ground state means only valence shell, you know that already. So it has 2s2 and 2p. P means you have 3 degenerating orbitals. So 2p is empty, this is 2s and this is 2p. So in first excited state, if you see, it has 1 electron here and 1 electron here. Okay, so that beryllium, this is the first excited state of whom? Beryllium actually. So beryllium can use how many orbitals for hybridization? 2. You know hybridization formula also. So BeH2, if you see, BCl2, if you see, this hybridization is what? Beryllium is 2 and 2 chlorines, 2 plus 2 by 2, just refer chemical bonding. And you have 4 by 2, 4 by 2 means 2, 2 means sp. And I shown here one s orbital and one p orbital. This is actually px and this is py and this is pz. Everybody knows. Correct? Huh? So here chlorine forms one bond, here chlorine forms one bond. The hybridization is sp actually. What I am trying to tell you, beryllium chloride as a monomer, it's sp hybridization. But in vapor phase, in what phase? In vapor phase, that beryllium has sp2 hybridization. Remember, this is the most important thing. Why? See this here, one more bond increased. This chlorine formed native bond with beryllium. So hybridization increased. So one more empty orbital formed bond actually. So now in this particular vapor phase, as a dimer, if they ask, that is important. As a dimer, in BeCl2, the beryllium hybridization is, if they ask, then you have to say your beryllium hybridization is sp2. sp2. Remember, in vapor phase, as a dimer, the beryllium hybridization is sp2 because one more bond increased. Why? Two empty orbitals are there. I told you in previous, do you remember? Beryllium exhibit covalency 4. This is only the reason. Two vacant orbitals are there. Two already used for bonding in first excited state. So here two, and empty orbitals also can involve in hybridization. I told you in chemical bonding. So in that way, as beryllium is a small and beryllium has a covalent character, that's why only beryllium compounds have hybridization. That's why only beryllium exhibit maximum covalency 4. Otherwise you will ask me, sir, magnesium also have same configuration? No sir. Valence shell is same? No sir. Then beryllium also, magnesium also have empty orbitals? No sir. Why magnesium is not having hybridization? Why magnesium is not exhibiting sp2, sp3, those kind of hybridizations? Means magnesium compounds are purely ionic. We are saying hybridization only for covalent molecules. So that is only the thing you have to remember. So BeCl2 in vapor phase, that exists as what? Dimer. In dimer, that one more bond extra, red color I shown here. So three bonds, two bonds actually, BeCl2 linear. BeCl2 means everybody knows, I think so. Yeah, I'll write here. So here I write. Sorry. Be Cl and Cl. Sorry. Cl, B and Cl. Actually linear, 180 degrees. It's normal, monomer, as a monomer. If they ask dimer in vapor phase, they will mention clearly. Otherwise, a question will become controversy. Okay. So dimer like that, especially they will mention. Then only you have to say in vapor phase as dimer, beryllium hybridization is sp2. Next, one more important thing is BeCl2 in solid state. In what state? Solid state. It exhibit polymeric structure, or it has polymeric structure. What structure? Polymeric structure. In this structure only, BeCl2 in solid state only, remember now only I am telling you, this beryllium hybridization is sp3 now. sp3 means non-planar. How many bonds you will have? 4. Everybody knows. How will be the structure? Let's see. B and Cl, Cl. Cl, B. Okay. Cl and Cl. And next B and Cl, like this polymeric structure. Okay. If you have more energy, you can write very big polymeric structure. It's not much important. So here BeCl2, this is one molecule. BeCl2 one molecule. BeCl2 one molecule. What about these chlorines, sir? These two chlorines, last chlorines are belongs to another BeCl2 molecule. Understanding? So this beryllium utilizing 4 orbitals. Here one with unpaired electron, one with unpaired electron. Understanding? So beryllium utilizes 2 unpaired electrons, here one and here one. These two are empty orbital bonds formed by using these empty orbitals here. So each beryllium now using 4 orbitals, 1, 2, 3, 4. Now this one also utilize same 4, this one also utilize 4. Like that it forms polymer, long chain. So what I am telling you here, as BeCl2 in solid state, that beryllium has sp3 hybridization and having how many bonds? 4 bonds. So here what is the covalency? Covalency is 4. So becoming non-planar. BeCl2 is planar in vapor phase and normal monomer. because sp2 means trigonal planar, sp2 means, but BeCl2 in solid phase exists as a polymer like this. So each beryllium, how forming 4 bonds understanding? By using 2 orbitals with 2 unpaired electrons and 2 empty orbitals, vacant orbitals. Total, each beryllium utilizing 4 orbitals for formation of this polymer in solid state. Who is forming? BeCl2 is forming this kind of polymer in solid state. There BeCl2 has sp3 hybridization. Please have a screenshot and write down. This is very important. BeCl2 actually what hybridization? sp. BeCl2 in vapor phase as dimer. If they said specially vapor phase, if they mention, you have to say sp2. Understanding? If somebody not giving a marks, you just ask me. You just say my name, no problem. Okay, BeCl2 in solid state, what happens? It forms polymer. There, beryllium has 4 valency as BeCl2. This is useful. We will use for AlCl3 also. Okay, similar concept we use for aluminum chloride, AlCl3, like polymer. So here if you understand, there it will be easy for you. Okay, next I think 4 or 5. Next, reaction with water. Reaction with what? Water. Okay, what next means? Water, actually beryllium cannot react with water. Beryllium, now I am saying beryllium can't react or react in water. You can write first. Okay, but remaining form hydroxides. Beryllium cannot react with water, but beryllium hydroxide also possible by hydrolysis process. Like BeCl2 can dissolve in water, but like this not possible. Beryllium with water, BeOH twice, not possible. Understanding everyone? This is not possible actually. Got it? But what is possible, sir, means actually beryllium chloride when react with the water, now BeOH twice. This is called hydrolysis process. This is possible. BeOH twice now possible. 2 moles required and 2 moles of HCl. That is not possible. So beryllium cannot dissolve in water. Important question. Understanding? So this hydrolysis is possible because BeCl2 is covalent, as I shown in previous, as I said in previous. But MgCl2 is ionic. So covalent molecules in water, they can undergo hydrolysis reactions. So very important. But remaining like M, I can write what can be M now? Magnesium, calcium, strontium, barium. Why I am not writing radium? Do you have any doubt like that? Radium is a radioactive, that's why I am not writing. Now just look at this. M plus water, you will get MOH twice, 2 moles and H2. Getting everyone? This is a possible, but beryllium I am not writing here actually. Getting, sir, everyone? So this is very important. And the most important thing in previous also I shown here, hydroxide. BeOH twice is amphoteric. But like remaining, if you see MgOH twice and Al, how it came? Sorry, calcium hydroxide CaOH twice and Mr. SrOH twice and Mr. BaOH twice. If you see, this is the order of basic nature. What nature? Basic nature increases. This beryllium hydroxide is amphoteric in nature. Remember, not only that, this beryllium oxide also amphoteric. Who is amphoteric? Beryllium oxide is amphoteric, which is very important. So in our next class we will finish this chapter. So beryllium anomalous behavior we have. Beryllium has a diagonal relationship with aluminum and compounds of calcium. That's it. This matter of half an hour. we will complete this. And next we have one small chapter, that is hydrogen and its compounds. So you have no need to worry about our syllabus completed almost. One small chapter is there. P block, where we will discuss, I told you already, in second PU P block we have one chapter. There you have nitrogen family to noble gases. So along with those you will have 13 and 14, that's it. Because P block at one place I will, with comparison, with some tricks I will explain. So pakka that will be useful, and because whole P block, from that you will have seven questions. Okay, so it's not easy, and I will make you that easy by giving some simple tricks for you. So P block at one place you will learn. So then what you have, just matter of 2 classes or 3 classes, one hydrogen and its compounds you have, that's it. So all the best and take care, as I said, and still if you have any doubts please ask me. Thank you.